Imagine a universe so vast, so infinite, that its end seems impossible. Yet what if everything, every star, every galaxy, even time itself, were destined to collapse into nothingness? Scientists have long debated the fate of our universe, and the most dramatic theory suggests that it might end the same way it began, with an explosion. But this time, instead of a big bang birthing new galaxies, it could be a catastrophic implosion. The Big Crunch. Our cosmic rewind, where the fabric of space shrinks, galaxies collide, and time itself crumbles under the weight of infinite gravity. Could this be the ultimate fate of everything we know? And if so, what happens next? Welcome to Cosmic Whispers, where we unravel the deepest mysteries of the cosmos. Every great journey starts with a few brave explorers. Right now, Cosmic Whispers is just beginning, and your support means everything. If you enjoy unraveling the mysteries of the universe, hit subscribe. It's free and it helps us grow this community together. Now, to understand how the universe might end, we first need to go back, way back to its beginning. Imagine rewinding time. Stars disappear, galaxies shrink, space itself collapses inward. If we keep going, back past the formation of the first stars, past the swirling clouds of gas and dust, past the first moments of atomic structure, we reach a singularity, a point so infinitely small, so infinitely dense, that it contained all of existence within it. This is where it all began, the Big Bang. Nearly 14 billion years ago, this singularity exploded, but not like an ordinary explosion. There was no sound, no fireball spreading into empty space, because space itself was created in that moment. The universe didn't expand into anything. It simply became. In a fraction of a second, it grew from the size of a subatomic particle to something far larger. And in that moment, the laws of physics as we know them were born. At first, everything was chaos. A roiling, searing plasma, hotter than a trillion suns, where energy and matter were interchangeable, locked in a violent dance. As the universe expanded, it cooled, allowing the first particles to form. Quarks, gluons, electrons. These fundamental building blocks eventually combined into atoms, primarily hydrogen and helium. Then, after a few 100 million years, gravity sculpted this gas into the first stars. These stars burned hot and lived fast, forging heavier elements in their cores, elements that would later become the building blocks of planets, moons, and life. But all of this, the stars, the galaxies, the very structure of the cosmos, depended on one key factor: expansion. The Big Bang wasn't just an explosion. It set space itself in motion, causing the universe to grow larger with time. But here's the big question: will it ever stop? And if it does, what then? For decades, physicists have grappled with this puzzle, and one of the most fascinating theories suggests a cyclical universe, a cosmic heartbeat of expansion and collapse. Imagine the entire cosmos reversing its course, galaxies slowing down, then stopping, then falling back toward each other as gravity pulls everything inward. Space shrinks, time warps, and in the final moments, all existence is crushed back into a singularity, just like at the very start. And then, what? Another Big Bang, an endless cycle of rebirth and destruction, or does everything just end? It sounds like science fiction, but the idea of a collapsing universe isn't just speculation. Scientists have observed that the universe is expanding, but the key question is, will it ever slow down? For the big crunch to happen, gravity needs to be strong enough to eventually overcome this expansion, pulling everything back. And that's where dark energy comes in. This mysterious force, which makes up nearly 70% of the universe, seems to be pushing space apart at an accelerating rate. If dark energy continues to dominate, the universe may never stop expanding. But if gravity somehow wins in the end, the cosmos could be doomed to a catastrophic collapse. But before we dive into the battle between gravity and dark energy, let's take a closer look at the science behind cosmic expansion itself. How did we even discover that the universe is growing? And could the very force that caused the Big Bang be setting the stage for its ultimate undoing? If the universe is expanding, how did we even figure that out? After all, we're tiny specks on a small planet orbiting an ordinary star in a galaxy among trillions. How could we possibly know that the entire cosmos is stretching? The answer lies in light, ancient light traveling across the universe, carrying secrets of the past. It all started in the early 20th century when astronomers peered through their telescopes and noticed something strange. A brilliant astronomer named Vesto Slipher was studying distant galaxies when he saw that their light was shifting toward the red end of the spectrum. This phenomenon, known as redshift, was a clue, one that would change everything. To understand why redshift matters, imagine a fire truck racing toward you with its siren blaring. As it approaches, the sound waves compress, making the siren's pitch higher. But as it speeds away, the sound waves stretch, lowering the pitch. This is the Doppler effect, and it happens with light too. If a galaxy is moving toward us, its light gets squished toward the blue end of the spectrum. If it's moving away, its light stretches toward the red. And Slipher's discovery? Every galaxy he observed was redshifted. They were all moving away. But how could that be? Was our galaxy just incredibly unpopular, everything fleeing from us, or was something bigger happening? Enter Edwin Hubble, the man who took this mystery and cracked it wide open. In 1929, he made a stunning discovery. The farther a galaxy was from us, the faster it was moving away. This wasn't random, it was a pattern, a direct relationship between distance and speed. The universe wasn't just expanding. It was doing so in a way that suggested it had once been much, much smaller. This led to the revolutionary idea that everything had once been packed into a tiny, infinitely dense point, the moment of the Big Bang. This revelation rocked the scientific world. If galaxies were rushing away from each other now, had they once been closer together? Had the entire cosmos exploded outward from a single event? The evidence said yes. But it also led to a troubling question. If the universe had a beginning, could it also have an end? For decades, scientists debated what might happen to this expansion. Would it go on forever? Would it slow and stop? Or would it reverse? The key to answering this lay in one invisible force: gravity. Every galaxy, every star, every atom has gravity pulling inward. And just as a ball thrown into the air eventually slows and falls back down, could gravity one day pull the entire universe back together? If there were enough mass in the universe, enough galaxies, enough stars, enough dark matter, then the combined gravity of all existence would be strong enough to halt expansion and trigger the ultimate collapse. This is the essence of the Big Crunch hypothesis. Imagine the entire cosmos slowing, like a car running out of gas. Over billions of years, galaxies would drift closer, the sky would darken as stars burned out, and the temperature of the universe would rise as space itself began to shrink. Gravity, the great sculptor of the cosmos, would become its executioner. At first, galaxy clusters would merge, swirling together in a gravitational ballet. Then, individual galaxies would crash, black holes would devour entire star systems, and eventually everything, every planet, every atom, would be drawn inward. The universe would shrink, growing hotter and denser until, just like in its first moments, all of existence would collapse into a single, infinite singularity. But here's where things get even stranger. Could this singularity explode again, creating another Big Bang? Could the universe be locked in an endless cycle? Big Bang, expansion, collapse, repeat? Some scientists have proposed that this cyclic model could explain why our universe has the properties it does. If this has happened before, if there have been countless universes before ours, then maybe the laws of physics themselves have been fine-tuned through cosmic rebirth. But not everyone is convinced, because there's one problem: something that could stop the Big Crunch from ever happening. Something more powerful than gravity working against it. That something is dark energy. In the late 1990s, two teams of astronomers set out to measure how much the universe's expansion was slowing down. They expected to find that it was gradually decelerating due to gravity, but what they found shocked them. The expansion wasn't slowing at all, it was speeding up. The universe wasn't just expanding, it was accelerating outward. And whatever was causing this repulsive force made up a staggering 70% of the cosmos. They called it dark energy, but the truth is we still don't know exactly what it is. It acts like an anti-gravity force, pushing space apart instead of pulling it together. And if dark energy is strong enough, then the universe will never stop expanding. The galaxies will never fall back. The big crunch will never come. Instead, a much more chilling fate could await us, a fate where expansion never ends. But if that's true, then what does it mean for the future of the cosmos? Will the universe simply drift into a cold, lifeless void? Or is there another possibility, one even more terrifying than the Big Crunch? To understand that, we must dive deeper into the mysterious battle between gravity and dark energy, and what it means for the end of time itself. For a long time, the universe's ultimate fate seemed like a battle between two forces, gravity pulling inward and expansion pushing outward. If gravity won, the cosmos would end in the Big Crunch, a final collapse into oblivion. But if expansion continued indefinitely, the universe would drift apart forever, slowly fading into nothingness. And then came dark energy, the invisible force rewriting everything we thought we knew. The shocking discovery in the late 1990s that the universe's expansion was not slowing down but instead accelerating. Through cosmology into chaos, the two competing scenarios, endless expansion versus gravitational collapse, had been the dominant theories. But now, there was a third possibility, one that was far stranger. To understand why, we have to go deeper into what dark energy actually is. Unlike gravity, which pulls objects together, dark energy seems to be doing the opposite, pushing space itself apart. And unlike ordinary forces, it doesn't weaken with distance. Instead, dark energy behaves more like a fundamental property of space itself, meaning that as the universe expands, dark energy becomes more powerful. The more space that exists, the more dark energy there is, leading to faster and faster expansion. This means that instead of galaxies gradually drifting apart over trillions of years, the acceleration of the universe could lead to something far more violent, something that some scientists call the Big Rip. Imagine this: billions of years from now, the expansion of space doesn't just separate galaxy clusters. It starts tearing galaxies apart. At first, distant galaxies will vanish beyond our cosmic horizon, moving away faster than the speed of light, lost forever. Then, dark energy's repulsive force would grow even stronger, overpowering the gravity holding galaxies together. Stars would be flung apart. Planets once held in perfect orbits would be hurled into the darkness. But it gets worse. As the expansion continues accelerating, dark energy could eventually overpower atomic forces. The very bonds holding molecules together, the glue of reality itself, would snap. In the final moments, everything would disintegrate. Stars, planets, atoms, even the fundamental particles of matter themselves. The universe wouldn't end in fire nor in ice, but in a silent, unimaginable dissolution of everything. But is this the final answer? Could dark energy really be this powerful? Or is there something even more mysterious at play? Some physicists believe that dark energy might not be a constant force. It could change over time. If that's the case, the fate of the universe isn't set in stone. Instead, dark energy might weaken, allowing gravity to reassert itself. And if that happens, then the Big Crunch could still be our destiny. There's another idea, a wild one, that suggests dark energy might not just push the universe apart, it might actually reset it. This idea comes from quantum physics, the strange world of subatomic particles where nothing is truly stable. If dark energy fluctuates, it could trigger a cosmic phase transition, a sudden shift in the nature of space itself. Think of water suddenly freezing into ice, but on a universal scale. If that happens, the very fabric of reality could collapse and restart in a new Big Bang. This is where the cyclic universe theory returns. Instead of a single Big Bang followed by a single ending, the universe might be trapped in an endless loop of expansion and rebirth. Her cosmic heartbeat spanning untold trillions of years. But here's the strangest part. If this cycle has happened before, how many times has it already occurred? Could there have been universes before ours, ones with different laws of physics, different histories, maybe even different forms of life. And if so, what if the next universe won't be anything like the one we know? The deeper we dive into these possibilities, the clearer it becomes. The end of our universe might not be the end of everything. But if that's true, what does it mean for us? Will anything survive? Will there be a way to escape, to leave behind a record of our existence before everything resets or tears apart? To answer that, we have to look beyond theories and numbers. We have to ask the most profound question of all. What happens to us when the universe dies? As we reach the final stretch of this cosmic journey, let's pause for a moment. All these theories, all these possibilities, do they really matter? Will the end of the universe affect us? Or will we, as insignificant specks in a vast, ever-expanding cosmos, be forgotten, lost to the darkness of a dead universe, or torn apart in some cataclysmic event we can't even imagine? The truth is, for most of us, these distant cosmic fates, the Big Crunch, the Big Rip, the cyclic universe, are far beyond the horizon of our daily lives. They seem so distant, so abstract. After all, we're here now, in this moment, and for the foreseeable future, we have time. But the question remains, how do we respond to the knowledge that everything we know, the stars above, the planets beneath our feet, even time itself, is temporary? It's a profound thought, isn't it? The universe may have started with a bang, a violent eruption of creation, but its end might be far less dramatic. No fiery supernova, no glorious final battle of light and darkness. Instead, we may face a long, slow fade, fading into a cold, dark void, or perhaps a violent unraveling, as the very fabric of existence disintegrates. But there's something else, something equally mind-blowing. We've explored the idea that the universe could collapse into a big crunch, pulled inward by gravity, only to explode once again in another big bang. Or that it could tear itself apart in a big rip, dissolving everything into nothingness. Or even that the universe could be caught in an eternal cycle of birth and rebirth, endlessly expanding and collapsing in an endless loop. But what if the universe's fate isn't determined by these grand cosmic forces at all? What if the end of the universe is something we've already begun to witness? You see, there's a lesser-known theory that's been gaining traction in recent years, the idea of cosmic entropy. Entropy is a fundamental principle of thermodynamics, the second law to be exact. It tells us that in any closed system, disorder always increases over time. In simple terms, the universe is running out of usable energy, and as it does, everything slowly moves towards a state of chaos. Stars burn out, galaxies drift apart, planets freeze. Eventually, in the far, far future, the universe will enter a phase known as the heat death. No more stars, no more light. Everything will be stretched out into a cold, dark expanse, with only faint remnants of matter drifting in the void. The very concept of time itself will lose all meaning as everything reaches a state of maximum entropy, where nothing can ever change again. It will be the final, quiet end of all things. But even in this seemingly hopeless scenario, there's a twist, a strange paradox. If we look at the universe's current state, we see that it's in a delicate balance, not expanding at a constant rate, but accelerating. This accelerating expansion means that the universe might not end in some clean, predictable way at all. Instead, it could slowly spread out, drawing galaxies so far apart that they will never interact with each other again. Life, if it exists elsewhere in the universe, will likely fade into the distance, isolated in dark, empty corners of the cosmos. And yet, even as the universe seems to die, it is still changing, still evolving. That constant state of expansion, no matter how cold or empty, means that the universe is still alive in its own strange way. In the deepest corners of space, unknown forces may be at work, perhaps even guiding the creation of new realities, perhaps even life in forms we cannot yet fathom. What does this mean for us then? If the universe is indeed heading towards some kind of end, whether a big crunch, a big rip, or a slow inevitable fade into darkness, we are witnessing it in our own tiny way through the study of distant galaxies, black holes, and dark energy. And while we may never live to see the end, we're participating in the most incredible journey of all, the unfolding story of existence. Here's the key thought I want you to walk away with. We are living in the middle of a cosmic adventure. The universe is still expanding. It's still evolving. It's still full of mysteries waiting to be discovered. Every time we look at the stars, we are witnessing a fleeting moment in a never-ending story that stretches across time, from the Big Bang to the distant future, and possibly beyond. We can't know for sure how the universe will end, whether it will collapse, tear itself apart, or drift into an eternal void. What we do know, however, is that the story isn't over yet. And maybe, just maybe, that's the most exciting part of all. So what do you think? Do you believe the universe will end like it began, violently and abruptly in a big bang or a big crunch? Or will it slowly fade into nothingness? Or is the end something else entirely, something we can't even imagine? Yet one thing is certain. As long as we continue to ask questions, explore the unknown and search for answers, the journey itself will always be worth it. Thank you for joining me on this cosmic adventure. If you've enjoyed this exploration into the mysteries of the universe, please like, share, and comment below. Let me know your thoughts on the universe's fate and what theories intrigue you the most. And remember, no matter how small we are in the grand scheme of things, we're all part of this infinite journey. The story is still being written, and we're in the middle of it.